for a while. Well, Tricia, when you agreed to do this, and then you said, "Oh, I'll have Brad come on too," I'm like, "Oh, wait, I get both? This is even better." But we are live. I can see that. So welcome everybody to Making Awesome Season 2, Episode 24. We are here hanging out with the Virtual Foundry. We got Tricia and Brad. They are the powerhouses of what make the Virtual Foundry awesome. And I could go into what everything is that the Virtual Foundry is, but I feel like I can't do it justice. Tricia, do you mind introducing yourself, talking a little bit about the company, and then Brad, you'll be next.
Yeah, happy to. Thanks, Grant. I really appreciate the invitation to come and talk to you today. I know it's going to be a lot of fun. So yes, I'm Tricia Cease. I'm the president of the Virtual Foundry, which means I do all the business stuff here. You're going to hear from Brad next. He handles all the science, which I'm very thankful for. Science is not my strong suit. He's awesome at it. So it works really well. So what we're all about here is possibility. And we provide that possibility through metal 3D printing that's accessible to everybody. So our main product is Filamet, which is metal filament that works in common off-the-shelf FFF, FDM style 3D printers. So you're printing this metal filament, which is made of metal powder encased in a plastic binder on your regular 3D printer. And then you can go through a debind and heat process to get that plastic out of there, fuse those metal particles together, and now you've got a full metal part that you printed on your ENDER 3D printer or any other FDM style of 3D printer.
Yeah, it's kind of amazing. Brad?
Sure, question?
Yeah, tell us about yourself. Let us know.
Sorry. Okay.
Folks at home.
Right. Okay. So I started out, actually, when I started this project, I was an application developer, software engineer kind of thing, a giant insurance company, and I had spent about a decade in a cube and I was done. And 3D printing came along and it was particularly interesting as a software developer because it had everything you need. It's got data, it's got logic, combined with some really cool robotics. So I immediately became interested in it. And I got a printer bot simple, the plywood and zip tie version of it, which was pretty cool. So I spent a few weeks putting that together. I spent another 2 weeks trying to get my first print successfully and got all done. And I had what to me felt sort of like a Happy Meal toy. And at this point, I had already been developing methods of working with metal that were more accessible than having a foundry. So the Virtual Foundry, the name actually predates my 3D printing involvement by at least a decade. So I was working on electroplating, electroforming, just anything I could think of to be able to make parts and sculpture that didn't require molten metal. And I had been working with powder metallurgy also, and there's a technology out there called precious metal clays. It's something that Mitsubishi invented in the 80s. So that concept was pretty mature, and it set me on a mission to combine them, to come up with an inexpensive method of 3D printing metal parts. And that's how, that's what kind of set the pace. So I spent literally years, it's been 7 years now. I had enough early successes to produce just enough filament in my basement to prove the concept. So I used my printer bot simple to print some very...
Oh man, old school, yeah.
Yeah, and so...
This was like circa 2011, 2012 then, right?
Yeah, it sounds about right. I filed my patent in 2013, and okay. I think, do you know what year it was approved, Tricia? I can't remember. It was like a 2 or 3 year process. So So that whole thing took a while, but I had a.
We can talk about that if you want.
I
I am well aware of the problems in the USPTO.
That's its own story.
Yes, it is.
And financing it is also its own story. So,
Yeah.
but I was able to produce some parts that looked good. And I did a Kickstarter campaign. So I had photos of the parts that I was making. And I actually gathered some very interesting supporters. And some of them were Lockheed Martin engineers.
No kidding.
Right. So the moment they saw it, they understood the potential in the way that I did. And part of the challenge over the years has been getting people to understand what we're trying to do here.
Right.
And as additive manufacturing evolves, that's just going to continue. It's an ongoing effort. But anyway, so those people recognized it, and I got an invitation. I went out to Lockheed Martin. I actually got to go out there. I gave my spiel. I gave my presentation. I got to speak in the Hubble Auditorium to all of their engineers. It was really cool.
Was that when you peaked? Because like we worked with the Smithsonian like 2 years into the business, and I'm like, damn it, we peaked way too early. Was that your peak for all of this?
At the time, I thought it was the tipping point, but it most certainly was not the tipping point. But having buy-in from people that understood the technology and everything around it changed the way that I thought of it. It made it clear that this could be something that I go into full time.
Right. Yeah.
So, that's what I did. At that time, I was working in the basement. I was extruding material through one of the early versions of extruders that people were making at home, were made out of plumbing and windshield wiper motors and things like that.
Oh, like a Filextruder or something like that, right?
Yeah, but a DIY version of it.
Love them.
There was a name for it, but I can't remember it. It was like some guy won a contest to come up with the cheapest way to make filament, and this was it. And it was a drill bit, some plumbing,
yep,
a windshield wiper motor, and such. So I made my first few pounds of material that way. So proof of concept done. I had buy-in from some pretty high-end people that understood it. So I went for it. We did the Kickstarter. I raised about 107% of what we were going for. So we put it over the top, and just Kickstarters also don't work the way that you think they do. It's a lot more work than you would expect, and people don't just throw cash at you. So that was also its own experience. And all of a sudden, I was a new business with 400 orders to fill, and that was also challenging.
Yeah, that must have been an oh crap kind of moment, right?
Yeah.
We've talked about this before on the podcast, that overnight success can a lot of times equal failure, because you might not have been prepared to be like, all right, I needed to raise a bunch of money and I said I would make this stuff. I didn't think I was going to get this much.
Right.
I don't know what the hell we're going to do now. Was it one of those scenarios at that time?
Yeah, that was part of it. It was and when you think about it, you can expect the obvious. It's going to be hard to make this stuff. It's going to be hard to package it. The simple things that I overlooked were like people not typing in their addresses properly. So I did a lot of international shipping. So then things start coming back, and then I didn't. This was Tricia. This was when it was necessary for Tricia to bail me out. So as things were coming back, I lost track of what we had shipped. It became a bit chaotic. But like I said, we got through it. So I used the Kickstarter money to buy an antique commercial extruder off of eBay. And it's actually still the one that we use now. I've been upgrading it. I put new, more powerful motors on it, things like that. I've designed my own screws that go in the extruder.
Nice.
All the processing equipment that we have are built with Arduino. So
no kidding.
Yeah, I love the microcontroller stuff. I was way into that before I started this project. So now I'm pretty sure we built a manufacturing facility for less money than anyone possibly could. So we have equipment made out of the swivel part of an old Lazy Boy, a chunk of my old aquarium that we use for chilling the water that comes off the extruder. And it's all worked out great. And we're manufacturing at scale with mostly homebrew equipment or leftovers that I bought off of eBay and rehabbed.
We've got a bit of a saying here that if it's jank and it works, it's not jank, right?
Yeah.
Now, do we show it on camera? Hell no. You know, like on camera's got to look a little pretty, but
Right.
I would say if I'm going to have an ancient machine that I'm upgrading, there really isn't a non-jank way to do it without having a full machine shop at your, at your disposal. And if you had a full machine shop at your disposal, you probably wouldn't have gone with the antique machine. So, right. Remember, people, listeners out there in the radio, you guys can't just say, I'm going to raise 80 grand on Kickstarter and just figure it out as we go. That's not a great way to do it. You got to have the plan. And the plan was to get an older machine. Because if it's old, it's probably still good because they don't make them like they used to.
Yeah.
Right.
Yeah.
And you can make those old machines good with a little bit of tweaking. I would have not have expected Arduino.
Yep.
But that's pretty cool to see, just an 8-bit board making it into some of the most amazing metal filament that Enders can use.
Right.
That's my little marketing thing for this. It's metal that you can print in an Ender. Yep. But that's not 100% right, is it?
It is a precursor.
Yeah.
And lots of this metal 3D printing has become, at least in the cost scale that we're involved with, has become kind of some people use it as a misleading term. MakerBot is on a campaign where they say they make a metal 3D printer and it's under $10,000. But what it really is the same printers that all of us use, an FDM printer, but they put BASF ultrafused material through it. So no, that is not exact. And we really try not to use terms that these are a direct metal 3D printer. That's not how it works. No. It creates a precursor, a green part, but the green part can be debound. So you can take the plastic out of it using only heat. So, and I've spent years developing this polymer, and what it does, as you raise the temperature, it vaporizes without going to a liquid state in between. So the part doesn't melt. It sublimates.
Sublimate? Right?
Yeah, so the binder sublimates at the proper temperatures. All right. So we have a heating schedule. You run it through carefully, and the binder comes out of it, and you're left with a brown part, which is powdered metal held together by a minimal amount of binder that gets left behind, and sometimes it's a bit of the oxides and the metal particles.
Right.
But it's a part you can pick up, you can hold, and you put it in a kiln and heat it up the rest of the way. The particles weld, and you have a pure metal part.
So we got a question in the comments from Geek Toy Box asking, how well do the prints hold shape during the kiln process? I know that answer is very much it depends, but Can you go into that a little bit?
Right. So there's a lot of moving parts here.
Yeah.
And much of this depends on how dense you want your parts.
Right.
So the way it's designed, if you remove only the plastic, the distance that the particles move together shrinks the overall part by about 7.5%. At that point, you can sinter it into a rigid, pure metal object, but it remains quite porous, so it's spongy. So this is long for, if you're willing to or able to work with a porous part, you can have highly accurate pieces at the end. And I actually probably should have worked with this out with you before, but would it be okay if I shared some images here?
Yeah, do you want to share your screen?
Yeah.
Okay, let me know when you're ready.
There's a relationship between the density, the
Yes.
shrinkage, and the potential for part shape change. So the more dense you want your part, the more it's going to shrink, the more potential for shape change.
Yep.
But these are all things that can be. So you run through the process based on the result you want to get, study the result, adjust the process, and so
Right.
on.
Yeah, and that's the nice thing. Your filament, excuse me, is so affordable, and you all might be looking at saying, "Wait a minute, my Ender 3 costs less than this." You're printing in metal. Stop it. All right, stop it. Go look at what
Yes.
everybody else is charging for this kind of stuff, and then realize the deal you're getting. It is considerably affordable when you look at it. And the fact
Right.
that you don't have to do the sintering yourself, if you got the ability to do it, by all means. But the Virtual Foundry offers sintering with a dedicated partner that they've pre-vetted and done all the work with. So you know the parts are going to come back reasonably good as long as they're designed to be made via metal AM, additive manufacturing.
Yeah.
You have to design it that way.
Right. And there is, so getting into the quagmire, there's a couple other $200,000 solutions out there, the Markforged Metal X and the Desktop Metal Studio System.
Yep.
And what they've done is they've designed a slicer that bakes in what you just described. So it will let you make mistakes, or, this is their strategy. They slice it so that it's more appropriate for the debinding and sintering process.
Yep.
So using our route, you kind of have to understand how it works and program that in and deal with it when you're going through the slicer. And we just use Cura. And we tell people, just set up for PLA, turn your temperature up to 225, turn your extrusion rate to 130, and go. And you'll get a successful print.
Wow.
Okay, are you ready to share my screen here?
Go ahead.
And for years I resisted. I said I would never do a Benchy, but here we are. So this is a pure copper Benchy. And I decided to just do it because it's a shape everyone's familiar with.
Everyone knows the Benchy.
Yeah. So the surface is a bit rough here. I just left it as is. I took this off the printer and sintered it.
Okay.
So when you get in there, you can see each of the line layers is visible. It's easy to see. You have fingerprint level detail.
You do, yeah.
Brad, when you're showing that level of detail, what was the shrinkage on that part?
7.5%.
That's
Okay,
not bad
so
at all.
in that case, you're following the directions that we have posted on our website, which is going to return about that 7.5% shrinkage. You're getting that level of detail. And then also the part has, what would you say, Brad? It's like 85% density?
Yeah, about 85 at that point. So the part that's on the screen now. So the one on the left is the Benchy off the printer. It's off of an Ender 5. The green part on the left, the brown part in the middle. So the part in the middle has very little binder left in it, just enough to hold it together. The part on the right, this one's shrunk more like 12%. And you can start to see some shifting in the shape of it. And this was my first run. So
Wow.
I would do the sinter job again, and I would be able to get there's a bit of slumping in the overhang in the middle part. Not sure what you call it, but I would overcome that with the next iteration. You simply exaggerate the Z or the X or however it's shrinking in the situation that you've created. And the more you shrink it, the higher the density. So if you shrink it 17 to 20%, you have 98, 99% density.
Right. Right.
And here, quick one. Here's our print farm.
So a little bit of everything there. Everything from, is that an Ultimaker 2 or an Ultimaker 3?
It's a 5S.
That's a 5S. Oh,
Yeah.
geez. To what appear to be Ender 5s, right?
Yep.
Yeah.
Those are all Ender 5s.
Yeah,
And you
so
can see
quite literally, you can 3D print metal on an Ender.
that's all we use.
Yeah, and if you look way back in the corner on the left, there's our original Ender 3,
Yep, there is an Ender 3 back there.
still in use.
Love it. Love
And
it.
our parts are getting bigger, so we're going to add an Ender 5 plus here shortly.
Nice. Okay.
Grant, if you don't mind, I'd like to answer a couple of questions that are coming in.
Sure, by all means.
Talking about printers. So the printer that's going to work best does have direct drive extruder.
Yep.
So the Ender brand comes with Bowdoin tube. We always recommend that you switch to direct drive, and especially dual gear is really going to be optimal. And then secondly, someone had mentioned earlier about hard nozzles, and yes, definitely you need something harder than brass. You can use brass, it'll just wear away very quickly. So a stainless or hardened steel nozzle sized at 0.6 millimeter or larger.
Yep. Yep.
And then Greek Toy Box is also asking about finishing techniques. So once your part has gone through the kiln process, you've got a sintered part at the end, it's a regular metal part. So yes, you can do anything to that you would with regular metal, welding, brazing, applying finishes like a patina in the case of copper and things like that.
Yeah, we generally point people to jewelers that do YouTube videos. There's just an infinite number of techniques you can use to finish your part.
Yeah. And so we say Anwar just asked that they believe that the Bowdoin tube would make it snap with friction. Maybe, but you guys have a solution to deal with this, right?
Right. And it's less about friction and it's more about path.
Right.
So our material, because of all that metal or that other ceramic or glass powder that's in there, is more brittle than regular plastic. So what you want to do is make the path from the spool to the printer as straight as possible. So as we saw when Brad showed our printers lined up, if you could pull that up again, Brad,
Yep.
We have a row of filament spools hanging from the ceiling so that the filament is coming straight down into the printer. And then additionally, if you can see them hanging from a bar up there, you'll see some filament spools just in the air. And then additionally, we created a tool called a filawarmer that heats the strand of filament as it's coming off the spool. So it's just heating that one strand at a time. Please don't bake the whole spool. You'll wreck the entire thing in one fell swoop. So you were going to only heat that one strand as it comes off the spool, making the path as straight as possible. So when we're talking about a Bowdoin tube and the material has to wind through that, that's when we're going to have the trouble with breaking.
Right.
That being said, you'll notice there's an Ultimaker 5S there, and those things print metal all day long. We have plenty of Ultimaker users. We do have them use the filawarmer, and the filawarmer is literally it's a little gadget I made with a piece of copper tubing in it and a heater. It has a mechanical switch in it at 65 degrees Celsius. So it'll warm up to 65 degrees and it always overshoots. So we get a cycle of heating and cooling as it goes through. And it does two things. It takes the memory, as it sits on the spool, it gets a memory.
Right.
The filawarmer will make it so that it'll come straight down off of the spool. And it also slightly anneals the material. So it's actually stronger after it goes through the filawarmer than it is directly off the spool.
Yeah, the filawarmer and this idea of basically wiping the memory of the filament, whether it's regular PLA, PETG, or metal bound filament, is completely been done for years, right? Yes. Especially for the 3mm crew. So hi, Ultimaker and Lulzbot users that still haven't figured it out that 175 is definitely better. That's why your filament snaps on your spools if you don't pull it out of your reverse Bowdoin tubes or your Bowdoin systems. It's because there's a memory in it. It's not because it's wet. Your filament's not wet. Stop it. He says this as I literally have a print that's running above me that actually is suffering from wet filament, and I'm excited to show it off on our Print Fix Friday. But nonetheless, Tricia, you have an interesting story.
Yeah.
And I heard your story at the Women in 3D Printing Convention, and I said, I gotta have you on this podcast. Like, I heard it, I'm like, wait, you did what? we need to talk about this. I need to share your story with as many people as possible. And you're like, but I want to bring the material guy too. I'm like, yes, please, let's do it. But Tricia, I want to hear about your story because you went from being a letter carrier to becoming the president of the Virtual Foundry. Can you talk about how that happened?
Well, the path between those two particular roles took about 30 years.
Yes.
So we'll start there. But yeah, I bill myself as a trier. I love to try different things. And once I know how to do something well, I move on to the next thing. So there have been a lot of different jobs. There have been a lot of different hobbies. So I drove semi-truck for a while. I've been a bartender. I've did some construction labor. I've managed the festivals in the city where I live. I served on our city council, just all kinds of different stuff. I did powerlifting for a while and dabbled with personal training. So it's all over the place. But the one constant that has been throughout that entire time is business. But I didn't really get it. Right. I thought that I knew or did business because it was the easy path. Well, it turns out I love it. So when I heard about what Brad was working on through his wife in his very early experiment time. So Brad and I live in the same city and we've known each other for quite a while through the same social circle. And I was good friends with his wife. So I don't mean to say I am good friends with his wife. And she was telling me about this project in the very early days. And it immediately sparked me. I immediately understood the potential and the possibility that went with this, even though I had had almost no exposure to 3D printing. I didn't really understand it. I don't even know if I'd seen a 3D printer at that point. But I got it. I knew immediately. So she would continue to kind of talk about it. I would talk about his progress. And I started saying things to her like, hey, when he's ready for some administrative help, can you just nudge him in my direction? Well, it turns out, yes, he did need some business help at one point. Brad was managing the science and the business, all of it.
It's tough to do that.
He's trying to develop it and manufacture it and sell it and raise money and everything all at the same time. So got to a point where he just really needed a lot of help. I was at a point in my job where I was ready to move on from it. And so he called me in for a meeting one day. We'd been talking a little bit about it. Was I interested? Yes. He told me about the business, things like that. And then set up a meeting with me and I came in and he said, I feel really weird putting it this way, but will you be my president? And I said, yes, I would. Obviously, I'm here now. I did not understand what I was getting myself into.
I understood.
He's like, she doesn't know. Let's go with it. She's good. Let's do it. So how long ago did you say yes to that?
That was early 2017.
Okay, not too bad.
So I consider my first official day to be July 1st, 2017. And I started on a part-time basis because I was still wrapping up some projects at my previous work. So then Labor Day 2017, I think is the time that I really came on full time.
Okay.
So I didn't know anything about metallurgy, science, technology, 3D printing, additive manufacturing, industry, any of our competitors, nothing. So it was this, as I said earlier, once I know how to do something well, I don't want to do it anymore. That it just isn't happening here. So there's this constant flow of new things to learn. So it's really been exciting. And I really love this industry because it's full of super creative people doing amazing things all the time.
Right.
And there's always something new coming out. And there are room for all technologies. So as a new thing comes out, it doesn't mean that the old thing goes away. We're just adding more possibility to the pool.
I like that. And I would agree with you, right? You guys are kind of taking the norm of metal 3D printing being inaccessible, too expensive, unreliable, and unrealistic for anyone that's not seeing a six-figure salary, saying, how about we change that narrative? You can do this at home. Yes, you have to send it out, unless you do want to buy the sintering equipment, which of course you guys do appear to sell. And you even have all the steps to sinter it appropriately listed right there, which, hi, anyone else out there that does metal AM, go try to find that on anybody else's website. Best of luck. Not only will you not find it, they will likely not tell you how to do it. They'll say you have to buy our machine or you can't do it. You guys are making this incredibly accessible to the average home gamer that has one, maybe two printers and wants to mess around a little bit and get serious with metal. That's pretty amazing.
We have a very open philosophy. So the only thing that we're not going to tell you is how to make the filament.
Right. Otherwise,
we want you to know all about the printers. We want you to know all about the kilns. And by the way, you don't have to use our kiln. You can use any. You can, there are a couple of requirements. It should be programmable and it should be able to hold the sinter temperature of what material you're working with.
Right.
Those are the only two parameters. Otherwise, you can get a kiln for a couple $100 if that's the route you want to go. And we're going to tell you how to use it. We're going to support you in using your own equipment to get the result that you want. We're going to educate you on the difference between us and other people in the metal AM space. It's an educational, very open information philosophy we have here, because the more people who gain the skill, the further we can take this. Brad likes to use the word democratization.
Yep, I would agree.
It doesn't quite roll off the tongue the way that I'd like it to, but it really is. It's the best descriptor of what's happening, the democratization of metal manufacturing. So the more people understand about it, the more we can move this new next manufacturing revolution forward.
Yeah, I want to try some of this out. I'm going to have to put an order in with you guys just to try it, because I've used your service in the past. We did it for some copper heat blocks that we needed for a very hardcore Raspberry Pi overclock that ultimately resulted in destroying the Raspberry Pi. The heater block worked great. Just our settings were adventurous, to say the least. The system was perfect. You told us what the shrink rate would be. We designed it for it. We had you all print it. It was sent out. It was sintered. It was delivered in a couple of weeks. The part fit exactly. I think we might have polished the top and bottom surface so we had better contact, but that was all that we did. The part was beautiful. It's just a cube of copper. It was just a little cube of copper. It was nothing special. But it was my first kind of iteration into filament-based metal printing. We've operated DMLS machines before where you're using metal powder and a laser to melt and selectively sinter. Those machines are high six-figure, low seven-figure for the cheaper ones, and multi-seven-figure for the ones that, the big ones. And while that is tough to compare the two, it's really not at the end of the day, right? This technology that you are enabling the average person to have access to is kind of ridiculous. Brad, can you talk a little bit about why you went into this? Because you were previously a software engineer, and you decided then, all right, let's go into metal AM. The both of you have really interesting previous lives before you found yourselves into the additive manufacturing industry. Brad, can you talk about what that jump was like for you?
Part of it was probably being a bit naive. I had the same level of faith in our product at that time that I do now. But I expected adoption of it to come much more quickly. I thought I was going to put an interesting solution out to industry, and industry was going to eat it up. And that's not how things work. So where we are now, and so in sort of the in the not home user category, we have a lot of adoption at the R&D level. Lots of students writing papers. I think we're up to somewhere between 12 and 15 thesis papers that have been written by students on our products in various applications.
That we know about.
Yeah, that we know about.
Yeah, we stumble upon them.
Yeah,
Do they
we'll find a
tell
new
you, or
one.
do you just happen to find them when you're Googling around?
Sometimes they tell us, otherwise we kind of happen to find them too.
Right, and a lot of them are behind paywalls, so we
Yay.
don't know about them. But the ones that we've found, there's 12 of them, and we publish links on our website. So the whole thing just worked a bit differently than I understood at the time, and I was just done with software. I'd spent my whole life in software and project management. And there is just something nice about having a physical product when you're done, rather than spending years on a multi-million-dollar intranet project that nobody ever sees. And it's not like you can, show pictures of it to people or things like that. Just having a physical object has been so much better for my brain.
That's fair. We have a few of my close friends are in the software industry, and they are starting to get 3D printers, and I feel personally responsible for this, so I'm making sure they don't get printers that they're going to hate. But it is interesting to watch them, because again, they're like you, they're programming and they're seeing it on a computer screen. Now they're programming and they're able to hold it in their hands, and it's a completely different thought process that occurs here. Now,
Right.
was it a slow process for you from that move over from software to hardware, more or less, or was it something that you did gradually over the course of a few months or a year?
No, it was a hard shift. I left my job and started doing this, and needed it to pay me within months. So
I feel that. I feel that.
right.
I do. Could you explain to the viewers here who aren't immediately familiar about metal 3D printing how the traditional method is done, whether it's, like the DM Studio, the Markforged Metal X, or even like a DMLS from your perspective? Because I can explain it, and I did a little bit, but I feel like I'm nowhere near as qualified as you or Tricia to talk about this.
Actually, if you wouldn't mind, Tricia, you do a very good job conveying this, if you wouldn't mind.
Sure. So we're in the FDM FFF sphere. Desktop Metal, Markforged Metal X, same. BASF Ultrafuse, same. We're all using Fused Deposition Modeling technique, fused filament fabrication. So the 3D printers that are in the Desktop Metal Studio system are the same. The material that's going in them is not in a filament form. It's Desktop Metal makes more like a pretzel rod shape. So they have skirted the challenge of getting the material into that filament line by using a different shape. However, the printing process is the same. And we move up then to the powder bed processes. And there you're talking about direct metal laser sintering and binder jetting. So binder jetting, DMLS are using the same basic process where you've got a bin of metal powder and a flat surface. So the machine will apply a thin layer of metal powder to that flat surface. In the case of DMLS, it's going to shoot lasers at the metal powder in exactly the shape that you're building. Then another layer of powder is applied, more lasers, powder, laser, powder, laser. And that's how you're building the shape. And in this case, you're sintering in place as the object is being built. With binder jet, it's got that same metal powder layer application, but instead of lasers, it's applying glue or a binder. So a layer of powder, glue in the shape that you're building, powder, glue, powder, glue. Now, what you've got at the end of that build process is a green part that's essentially the same as what we have here that we've 3D printed, a green part. It's metal powder with a binder applied. So a binder jet part is also going to need to go through a debind and sinter process as well. Then from there it branches off into every crazy thing. So people
Right.
are trying to actually lay down a line of metal and fire it in place or like melt it into place. Direct energy deposition. There's atom. It gets into all kinds of crazy, all kinds of stuff. People are coming up with the new technologies all the time, but really the ones that are really taking hold are the DMLS, the binder jet, and the FDM style.
And you kind of notice a theme. So most of them, they're based on powder metallurgy. So
Right.
you're starting with powder metal and you're binding it together in some way.
Now, the powdered metal that is being utilized in your system, is it similar to what one would be using on a powder metal system like a DMLS or SLM style system? Are we looking at the same rough granular size, or
Yeah,
or is that
it's
proprietary and I don't know?
Oh no, it's the same. So we're using
Okay.
the same vendors. We're buying the same powder.
Yeah, we buy that powder and make it into filament.
Yep.
That's cool. That's cool. Okay, so so theoretically then, the big difference between, and I'm going to kind of get rid of DMLS on this one, because that's all about laser spot size. It comes down to quite literally machine positional accuracy and nozzle diameter is where your accuracy comes from, right?
If you're talking about possible resolution and the amount level of detail, yep, it's going to be in the FDM situation. It's going to be layer height and nozzle width diameter.
Right.
So our method of metal 3D printing has the same limitations as FDM. So the best FDM that you can print is the best metal you can print.
But I can print with a 0.1 millimeter nozzle. Why can't I print metal with a 0.1 millimeter nozzle?
That's
and you can. Okay, so
with a 0.1, there's no way.
No,
the particle size.
Not a 0.1. We printed our tungsten material with a 0.3.
Wow.
So 0.3 is pretty good.
Yeah.
All of the numbers that we published are to get people to the most likely success initially. We recommend that all of the parameters be explored for improvement as you go along. But initially, we want people to succeed out of the box, and that's what our parameters describe.
Yeah.
Your most likely victory.
Looking at your site, it's 0.6 for most of the materials, 0.8 for the high iron, right?
Yeah.
The high carbon iron.
Or high carbon iron, yeah. Which makes sense, right? Lots of carbon means you're gonna need a bigger nozzle. So those out there that are like, well, I want to feed it through a 0.4. If it clogs, it's your own dang fault.
Yep.
For those that don't have experience printing in carbon fiber, I highly recommend starting with that. Of course, you guys sell a carbon fiber PLA that I saw, so you can start with that material. Learn carbon fiber first, because from my understanding, they're pretty similar in terms of the ways you print with it, right?
Probably. We don't have a lot of experience with carbon fiber outside of that we manufacture ourselves.
Oh, okay.
And we use it internally just because it works so much like our metal. So maybe you're making a really good point that we should have spotted earlier. But
so
the main reason that we make a carbon fiber at all is that our superpower is putting additives into filament. So I was like, well, okay, well, let's put some carbon fiber in the filament. And we did. And it's what we use primarily in-house anytime we're printing anything that's not metal.
Well, the carts right there, that last cart, the white cart, that is full of carbon fiber and glass fiber filled materials. That's our exotic cart.
Right.
So we do a lot of exotic printing here because people will generally ask for, say, well, I want carbon fiber filled material, or I want metal. We get a lot of people say they want metal 3D printing. I said, okay, what's your application? Oh, well, I've always wanted to make this figurine out of metal. I said, then cast it.
Yeah.
Metal 3D printing is not designed for this. You're wasting tons of time and money on it. And yes, you can do it. But they're talking like, a 2-inch tall figurine for their Dungeons and Dragons campaign. It's not exactly what metal 3D printing is for, right?
Yeah, you're kind of segueing into one of our key challenges, and that is getting people to think of applications that are appropriate for the technology.
Education.
Yeah, so DFAM, design for additive manufacturing. This is a huge, huge topic. Tricia, I think you're about to say something.
Oh, yes. If somebody comes to us saying they want the look of metal, but it's going to be a showpiece, they don't want to go through the heat process, I would direct them to color fab.
Yeah, print it.
If they want something, but if they want something with more heft, so we do have people who are using the material for artistic applications, sculpture, showpieces, a trophy, and they want something with more of the heft and the feel, and a more of a look of metal. Yeah, use filament. Awesome. If it's not right for everybody, especially if people are a little afraid of the price, color fab is a great way to go if you want a metal look without going through the full metal process.
Yeah, we have a user that's a museum in Italy that reproduces parts like from their exhibits. So then they 3D print miniature busts and things like that out of our material and sell them in their gift shop.
That to me is totally fine, right? You're taking a piece of art, you're replicating it in the like material.
Right.
That falls well within, the realm of, yeah, this makes total sense. And then
right.
when you're selling it as an item like that, you get to play the "this is 3D printed" card,
Oh,
which
yeah.
I think adds at least 15 or 20% to the value that you can get out of it, right? If it's cast in mass, it's not as cool as every single one of these is technically unique.
Right.
And no two will be the same. Get one today, right? Something
right.
along those lines.
Yeah, I mean, there's lots of applications. Some are not appropriate. A key challenge is people come in and they want to, obviously hyperbole here, but they'll say, they want to print a trailer hitch. It's like, no, you don't. You don't want to. You don't want to do that.
No, you don't. Go buy one. we
For
have
an engine part, right? People want to take. Well, we can get into this more. I do want to pay attention to that questions that people are asking.
Yep.
But people want to take a part that's been machined. It's a big solid block, and they're like, "Hey, now I can 3D print it in metal." Well, yes, but there's a better way that we can think about this.
Yep.
And this is the design for additive manufacturing topic, which I don't think we can talk about enough.
Yeah, DFAM it is a big deal, something that if you're not used to doing it, pay somebody, because it will be something that you can pick up over time. But if you've got a mission critical project, pay for it, right? Because buy once, cry once, or you're going to do it a few different times. We do have a couple of questions, and they're all kind of residing around metal in resin. So is there any plans for a metal resin so that we could take our resin 3D printers and have resin in there?
From the scientist side of me, I would love to do that. And we've toyed a bit around the edges. We have lots of metal powder, and I have a pretty nice collection of resin here, but it's not a good time for us to not focus on our core business.
Yeah, I've done some testing with it. I know Tom Sadlatterer has tried it as well. He did a whole video on it. The big issue with resin is that the metal will sink to the bottom, which is where the screen or the film is, so you can use your laser to cure it. And you're gonna have a problem with all the metal being on the first 5 or 6 layers and then nowhere else in the parts. That was always my understanding of what made that difficult, is keeping it in suspension.
Yeah, we have some users that work with a ceramic material that they seem to have some success with. I can't think of the name of it.
That's the Porcelite from Tethon 3D, I think they're one of the few that make a decent ceramic material.
Yeah, do you remember, Tricia? We talked to them at Rapid.
I don't remember.
I don't either. Sorry. I'd like to plug their product, but I can't think of their name.
Oh, you and we have Geek Toy Box asking, aside from carbon fiber filament, which material is best to start with? So it appears they'd like to maybe make a purchase, what would you
Awesome.
guys recommend? Something that you start with.
Copper.
Copper.
We recommend, what were you going to, oh, I was going to say bronze.
Oh,
But
the copper alloy. The copper and the
Yeah, copper
bronze
or
are equally easy to use. It was
yes,
our first.
definitely copper or bronze. Yeah.
Yeah, it was our first product. It's the most mature. We have the most experience with it. We have the most people that work with it. So there are other users you can get some support from out in our forums and in our Reddit community, things like that. There's other people to talk to. Yeah, that's the easiest place to start. Also, it's one of the least expensive.
Yes, it is. It's actually quite affordable.
Somebody had asked earlier about what materials are available. And Grant, I know you shot him a link to the shop.
Yep.
Additionally, we make custom materials too. So the manufacturing process is the same no matter what final material we're making. So we've got the binder, that's a standard, and we've got the base material that we add into it. So we can do this process with nearly any metal alloy, ceramic, glass product. So we do make custom filaments for people. We've made a molybdenum, which I really like to talk about because it took me a long time to say it that easily. And so bismuth, and we've made a moon dust simulant, which is basalt, but that project is super exciting. There's a company that wants to build structures on the moon using our technology or using the filament manufacturing, printing, sintering technology. So they sent us a moon dust simulant to make into 3D printing filament. That was super
cool.
Yeah. Moon dust can be sintered.
Other variations of titanium. So those custom projects are a lot of fun.
Nice.
And we're getting into even more unique composites. So we'll do a metal combined with a carbon fiber. We've done differently doped bismuth for 3D printing in situ thermoelectric cooling devices. So it just gets crazier and crazier. And there's one of the more recent papers that we shared on our website. It's a lab in Finland that took multiple different metals that we make and then sintered them into a new alloy after the processing. So they're creating alloys on the fly, things like that. It's getting more and more interesting.
We just had a bunch of comments come in. Have you tried sintering a vase mode print?
Yes.
How's that work?
It works well. It's hard to not get very tiny gaps between the lines because there's a tendency for the materials to pull apart.
Yeah. But
yeah, you can print single layer lines or either vertical or horizontal, and they'll sinter all day long. You can make a piece of foil that you can bend.
No kidding. That's cool. This one is from Holler Players. They said, what is the point of printing in metal if it can't be used for strength? I'd like to print some parts that will be strong for props and such, but not if it's too brittle. Well, if it's not sintered, it's going to be brittle.
Right. Yeah. If it's sintered, it has the property of the metal that you're working with. Right. So, I mean, copper is plenty strong for most applications. If you need something more rigid, use bronze.
Right.
Yeah, you're not going to make a part that's under heavy stress. Right. But there are lots of other applications that are not under heavy stress, and they're totally appropriate for that.
See, and so when it's fully sintered, you can toss it into a mill and mill it down to, a beautiful finish, right?
Yeah. In many applications, we recommend that people print a near net shape part. So finish up your drilling and machining as a post process.
Yeah. That way your holes are perfect and all the outside needs to be done. Red/Ace asks, wait, does your moon dust smell like gunpowder when it oxidizes? If it does, I need to get in touch. Red/Ace, his real name is Peter Sassaman. He makes a product called the Scent VR, the Cilia. So they add scent to a VR experience. So he's a guy all about making things smell good, bad, or at least the way they should.
Right. I learned more about lunar regolith than I ever thought possible. And first of all, there are companies that make simulants for the material on any planet that you can think of. So you can get Martian regolith, you can get lunar,
Yep.
and they're supposedly technically faithful, but I wouldn't know. But the most interesting thing I discovered about moon dust, well, one is that it's sinterable, and two, that it has a very high iron content. It'll actually stick to a magnet.
Huh.
I thought that was very, very interesting.
Do you remember any kind of smells with that material?
I do not know. Some of the materials we work with, like high carbon iron, tends to have an odor. Aluminum has an odor that's not very pleasant. But no, not that one. That was pretty inert.
We have some questions regarding sterling silver or gold. I don't see sterling silver or gold for sale on the website, but I do know it's possible. I know there are precious metal 3D printers out there. Is it something that you guys have tried out before?
Not yet.
It's a very expensive thing to prototype.
Yes. Yeah. So to that point, we are looking for sponsors to produce to help us produce a silver and or gold filament.
Yeah.
So in this way, basically what we need help with is procuring the raw material.
Okay.
Yeah.
The metal in powder form. What's
the granular size needed? So if you are trying to find someone and they find this video, what would you be looking for from somebody?
Sure. What works best in our process is spheroid particles at -325 mesh, or where the majority of particles are at 45 micron and the rest fill in smaller. We can work with other sizes, but that's really the sweet spot.
Yeah. It gets more challenging when we get to a large percentage of the powder being submicron. Right. There's more and more surface area, and that's more that needs to be coated with the polymer, and that becomes increasingly challenging.
So we're looking for the highest apparent density balanced with the lowest surface area.
Yep.
So I can imagine that, when you're making the filament, a little bit of, high carbon iron on the floor is not going to make or break that production run, but right. Someone that sneezes while they're pouring in the gold powder is going to be losing their job. Yeah. Yeah. So I know EOS makes a precious metal 3D printer. It's based off their P110, but its build volume is tiny. We looked at it years ago. It was like 240,000, but a kilo of gold powder was almost 10 grand. So we said, that's going to be a no, considering the machine needed 5 kilos just to operate.
Oh, right. Yeah, that's the other problem with powder bed is it takes so much.
Yeah. We'll stick to doing it with resin and then getting it casted. Thanks.
Right. And lost resin, SLA, I mean, most jewelers know how to do that anyway. So those people are pretty well taken care of.
I'm imagining like trying to work a print so well that there is zero purging, because a purge line out of gold would cost me multiple dollars.
Right.
It's cool, like from a technical standpoint, to say that you can do it, but from a practical standpoint, I am at a loss as to what I would make if I had gold filament other than random things. I'd make a gold Benchy just so I could ball like that, but otherwise I don't think there's a big reason from my perspective as a service bureau.
Yeah, we're not sure it makes sense, but we are asked so often that we're kind of at a point where I think we just have to make some silver filament.
You do it just to shut them up, and if they buy it, they buy it kind of deal.
Yeah.
Silver is used in industry.
Yeah.
I don't know how yet. I still need to educate myself on this topic, but silver is used in industry. So that's a material that makes a little bit more sense. But Grant, you're right on with the gold topic. Anything that is gold is tiny, right? And so you're also faced with the limitations of the FDM style of object making.
Yeah. You guys already have some pretty amazing materials. I mean, you've got Inconel, which, kind of god tier materials when you're looking at metals. It's a metal that when you hit it, it just gets harder.
Right.
They make rocket engines out of Inconel. And
right.
I am trying to convince SJ, who is kind of, you know, the queen of Inconel, to come on the podcast and talk about their experience in Metal AM. But
Right.
Inconel is no joke.
No, the super alloys.
Yeah.
And there's some really cool stuff going on there. And that's an example where we just take that material would have wound up in a powder bed printer had we not bought it and made it into filament.
Right. And you've also got, I'm seeing titanium, this zirconium silicate, which is Zircopax is the trademark under it. That's really interesting, making ceramic materials. Can you talk about some of the use cases there? Because I'm thinking of some, but they're not all that practical.
Some of these we have to be very careful about how we choose our words, or some of the coolest things we do are under non-disclosure.
Isn't that the worst? Same
people
here.
People talk to us about the ceramics in heat applications.
Yeah,
right.
That's where I was looking at too. Insulation and
kiln furniture.
Dielectrics, places where you need good insulators.
Yep. We just got a question from Chris Polk. He is a little bit behind. He said, what does the sintering oven and kiln landscape look like these days? I know you guys sell one. You have your sintering partner, but what does it look like for the average person these days?
It's trending toward affordability. The whole concept of the kiln, people overthink this. It's a little box that gets really hot, and that's all it is. It doesn't need to be complex. It doesn't need to be high tech. I mean, you do want it to be efficient and safe,
right.
And for our process, it needs to be accurate. That's why we tell people don't use a programmable kiln controller, and any older kiln can be retrofitted with a modern controller, so that's not an issue. So yeah, they're becoming more affordable, and there's a couple I just noted. I can't think of the name of it, but like on Amazon, you're starting to see kilns that would do the job that are under $300,
which is kind of ridiculous, right?
You know,
I don't know if I want a $300 kiln, but
kilns are all over the place in pottery, in precious metal clay, and knife making. So kilns aren't scarce.
No.
Right. Well, let me caveat that with the current shortages of various materials and stainless steel, things like that. However, in kilns are quite common. So one company that you might look at as you're just getting started is Paragon. They have tabletop kilns that may be fairly accessible. I'm not super familiar with their line, but that's a brand. But also there's a website called Kiln Frog that will show you a wide variety. I think you input some of the parameters that you need, and it'll spit out a bunch of different brands for you.
That's nice. Is it KILNFROG?
Yes.
Okay. I'll put that.
Am I saying that right, Brad?
Yes.
Okay.
I'm gonna put that in the comments so people can see it.
Right, and all of the kilns that are designed for working with precious metal clay, or maybe glass beadwork and things like this, these are increasingly common hobbies where the equipment also just happens to work perfectly with our material. Knife making that Tricia mentioned, I think it's pretty interesting that blacksmithing is trending. I mean, people are getting more and more into it. So now one of our kiln partners is Even Heat, and their specialty is heat treatment kilns. So there's people that have very high-tech kiln setups in their workshop for making knives and things like that. It's pretty incredible.
So just pay attention to that max temperature. Look at the material that you're interested in. Look up the sintering temperature of it, which is listed on the products page of our website, and then make sure that the kiln that you're looking at can handle it.
I mean, literally, I'm looking at the Paragon SC3 max at 2000 Fahrenheit. It's 7 3/4 by 8 by 7 3/4. So basically, it'll fit most parts coming off of a Prusa or an Ender, and it's $1,500. And if you're going to take this kind of thing seriously, $1,500 is a drop in the bucket. That's what, 5 or 6 kilos of filament, right?
Right.
At that point, if you're going to do this professionally, or you're going to do it more than a handful of times, it pays to just invest. And then you have a whole different hobby that you can play in. Hi, all the other maker ADHD sufferers out there.
Right. And yeah, to clarify, every part that I made up until about, well, I started with a Paragon SC2. So that was what I did all of my development on. It's a perfectly suitable kiln.
So the kiln that's behind Brad, or like just to the right of his head there, is the kiln that we sell.
Okay.
So yes, definitely we want you to buy our kiln, but you don't have to. And if you want to take a look at that model, it's right in the shop.
Yeah,
Right.
I'm gonna look at it right now just so I can post a link to it.
And the ones that we sell they're premium. So like the thickness of the brick will be twice as wide as what you would get with a less expensive kiln, things like that. But you don't need to spend a lot of money to be successful.
But they're also vetted, right? And from a business standpoint, if you're out there looking for the cheapest thing, you're going to end up with the cheapest result. And if you end up spending a little bit of money to get something that's right, that works, that's good from the beginning, your kiln is right at about 3,000. You are going to get a better experience that way. Yeah, your max temp is 2350 Fahrenheit, 1288 C. Honestly, it looks a lot cooler too. So like, you know, from that perspective.
It's funny that you say that. When Brad first saw it, he really remarked on the look of it as well.
Which one are we talking about? Which model?
Even heat.
Oh, right.
Yeah, the Virtual Foundry kiln. Now, also, what's cool about this model is that you can program it from your phone.
Wait, what?
Yes.
Yeah.
Yeah.
No kidding.
Yeah, it's fully smartphone friendly, so you can be, you know, at the bar and check in on your sinter job and see what's up.
Don't leave kilns unattended, please. Like I'll put that disclaimer there so that if people do it and something goes wrong, you heard it here. Don't do that, right? It's like you should never leave printers unattended, but we all still do it.
They're about the same thing. Things only go wrong when you're not watching.
Oh, of course. That's the only time things ever go wrong. So you guys have a ton of materials that are available. Tricia, I want to hear from you first. What is your favorite material to print with from the Virtual Foundry?
Well, I will admit to you that I don't actually do very much printing. I like to have a 3D printer in my office, but it often gets taken for other projects.
It'll be there for a while, and
wow,
then
Brad.
we'll print a bunch of things. And
but I did print a little battleship in 17.4 for the son of a friend of mine. And I printed some tungsten washer parts. We should like for this actually.
Right.
That little tiny thing that was metal printed.
Yeah.
That's awesome.
So those are the kinds of things that I've done. I printed a plastic golf ball trophy statue for the Chamber of Commerce. That was fun.
And just we've spent all this time talking about sintering materials, but we do have a couple applications where we don't expect the main application to be sintering, and that's our tungsten material.
Okay.
So tungsten has the highest melting point on the entire periodic table, I believe.
Ridiculous, yeah.
Yeah. So sintering isn't particularly practical, but it's incredibly dense. It's about 19 grams per cc. So,
oh my gosh.
Yeah. So this let us make a 3D printing filament that has the general properties of lead. Right. So it blocks radiation. It's used for vibration dampening, things like that. So yeah, so not all of them are meant to be sintered, but you can sinter the tungsten. There's tricks and there's strategies. You can sinter it in the presence of a metal that melts at a lower melting point. It'll just absorb it, and then you can get to your part that way. So there's so much development to be done on the sintering side of things that we need people to pick this up and move the ball forward.
I'm looking at your website. It says the sintering temperature for tungsten is 2,200 degrees centigrade, or about 4,000 degrees Fahrenheit.
Yeah.
So basically, unless you're Elon Musk and you're able to catapult it into the sun, sintering it is pretty much unattainable by the average human.
Yep.
You'd have to use lasers, I would guess, to get that kind of heat,
I
right?
I can't, I mean, there's nothing else that can hold up to the heat to help you get that to that heat.
Yeah, yeah.
But there are things, start thinking outside the box and like maybe some plasma strategy, something like that. There are things. You just need a plasma containment chamber. And,
Wait, you don't have one of those laying around?
Right.
I've
You
got
need
that like
I'm
3 of
sure
them.
Brad will be building one out of
Right,
toxic
yeah.
chewing gum here eventually.
we need a tokamak.
Brad, are you the resident MacGyver in the shop? Is that what this is?
Yeah.
And Tricia's the one that says, "Don't do this. Please
Right.
don't do this. This is how we
Sometimes
have
he
workers'
does-
comp claims."
He does that stuff on the weekend and I don't know about it.
That's the trick. We'll see. She's here today. You got to be
Right.
careful.
Sometimes or he hasn't necessarily built a new machine in a while, but there was a time when I would come in on Monday and he'd say, "Hey, I made this new machine. We're gonna use it for packaging from now on. It has a treadmill motor and a slingshot." It's really incredible, the things that Brad is able to create from very little.
Was the goal originally with the Virtual Foundry to just make metal 3D printing more accessible? And has it evolved to also kind of taking jabs and stabs at some of the companies that are 10x your price for no valid reason?
We have a class of user that we call the spite user. So they make things using our process literally out of spite, just because you shouldn't be able to, and that makes it much more interesting. But no, I think the initial motivation was materials.
Yeah.
I think like most mechanically minded people at that time, this is early 2000s, my first thought when I saw a 3D printer is I want to make a 3D printer. But it didn't take long to realize that materials were going to become much more important than the printers. The printers became commoditized. They're just not that important. And I spend a lot of time preaching this, that it isn't the printer that's important, you know? So all these companies market around having a brand new metal 3D printer. Like that, it's not the printer that's important. They're all the same thing.
In the early days of the invention, there was no thought of the competition because there was no competition.
Yeah.
All of the other technologies came online after.
Yeah. I filed my patent before Desktop Metal Incorporated.
That's pretty cool. Wait a minute. You filed your patent before they incorporated. Is there a claim here that you could be making that you're choosing not to?
No.
Damn. That would have been kind of cool though, because of course, you know, Desktop Metal did just buy X1 for a large sum of money.
We were at Rapid, and I think my favorite comment, and we got this from a couple people, saying, I can't believe Desktop Metal hasn't bought you just to shut you up.
Honestly, I'm kind of surprised about that too.
Right.
Because it is kind of like you're literally just lighting fires under them constantly, like, oh, hey, remember that we exist, remember that we're a tenth of the price, and remember our people are getting just as good quality parts on sub $1,000 printers, and oh yeah, we run Enders in our print farm. We got to get you guys some Prusas. I think that putting some Prusas, because those are dual gear, direct drive, all metal hot end, they're E3D V6s, and fully open source, so it makes life pretty easy. I'm surprised that you were all Creality.
Yeah, Tricia needs one for her desk, so.
Yeah, I do.
Prusa Mark 3S's, they're good machines.
That I will chain to my table so it can't be taken for other projects.
And then Brad will learn to pick locks or just cut the chain. Why do you believe that we should be paying attention to the metal 3D printing technology? Why should the average consumer be looking at this?
You know, I believe that in the future, everyone will have a 3D printer in their home.
I sure hope.
Just like they do a computer. Now, it's probably not going to look how it does today.
Right.
But it will definitely be easy for people to just create objects out of essentially nothing in the future, right? this is the start of that. We're at the very beginning of the next manufacturing revolution. I mean, this technology, and I'm not talking about just the Virtual Foundry, but all of it together. This technology is as monumental as the invention of the steam engine, as the invention of the assembly line. We're just at the very beginning of it. I mean,
Right.
there's everywhere to go with it, and it's going to continue to evolve. So why should you do it? Well, why wouldn't you do it? It's the next thing. You're going to be doing it eventually.
Mhm.
It's just a matter of time when.
Right.
Just a matter of time when. I like it. I like it. Where do we see the Virtual Foundry in in 2022, right? A lot has changed in this industry. I think Metal AM as well as SPACs, but that's more public stuff. But I think Metal AM was a big move last year for companies, right? A lot of companies were adopting Metal AM on a non-trivial scale. Do you see that continuing into 22?
Yeah, absolutely. I think a lot of people that are in it as a hobby or are enthusiasts feel that it's much more mature at an industrial level than it really is. It's in its absolute infancy at an industrial level. And this was, like, I spoke of myself being naive when I rolled this out as an invention. And what I didn't understand is that in manufacturing, they won't implement a technology until it's been vetted for years. And
Right.
and everything they have installed, they have such a tremendous investment that they have very little motivation to change. And they're not going to change until they're motivated by improvements in cost or time or something like that. So where the Virtual Foundry is right now, we're heavily in research. So national labs are one of our key customers. I think there's 17 of them in the US, and
Wow.
and most of them are active customers of ours. Department of Energy, students, universities, MIT, Harvard setting up a lab for our product. So as we move through the research part of things, we'll eventually get into the implementation part of things, and we're looking forward to it.
Nice. You guys have a pretty niche business, right?
Yes.
Like we don't beat around the bush. There's basically no other competition out there that is not on the industrial side. You all are playing
Right.
very handily on the consumer, prosumer, and because we can industrial side.
Yep.
What does it take for you all to stand out and succeed? Because I've watched you all for a few years from a distance, but I've known about it. You all have grown considerably in the past few years. What has it taken to do all that?
Persistence.
Patience.
The market needed to develop.
Yeah.
So Brad created a product with no market, right? That's the opposite of what you're supposed to do if you want to succeed in business.
Yeah, Brad, come on.
Yeah.
God, get good. No,
Right.
look, I feel this same way, right? It's education. If people don't know about the technology, it's
Okay.
you're gonna have a problem.
So we've been waiting for the market to develop and mature to even know who we should be talking to. Well, now we got it, right?
Yep.
Research loves it. Master's students are doing their thesis projects on it and publishing papers. The research branches of the military are looking at it for, we can't know what applications they're looking at it for, but they're checking it out, right? They're working with it for different stuff. And the prosumer, like you mentioned,
Right.
People at home who enjoy investing in their hobbies. We're a little bit of industry, right? So as the technology goes further, as these students get really familiar with how to get the best result, they're going to take that into the workplace. This is certainly a long game, but the market is still developing. We're still so early. So what we need to do is just continue to persist, right? And help that market along and help massage those applications and those uses and make sure that people are successful. our big offering is flexibility and control over every step of the process, which
Right.
is perfect for research.
It's
Research
not common
doesn't-
to see that.
Right. Research doesn't want to have limits in their design and push a button. You know, they want to work with every step of the process. Now, being able to have design limits and push a button is appropriate for some people, and they really want that. That's not our offering. So just continuing to talk to the people who appreciate possibility, appreciate flexibility, appreciate control.
I like it. Are there markets that you had initially identified as good keys that have either not worked out at all, or ones that you've missed that have been amazing?
Yeah. Automotive, right? We thought the same thing. Oh, we're all going to be printing car parts with it. Brake pads and rotors, and here we go. No, that's not it. We had to figure that out ourselves too, before we could start telling other people that that's not where it is. And the one that we missed was research. So education has been our largest buying segment from the very beginning. And we still were thinking about industry, manufacturing, automotive. So we've had to adjust our own idea of what the technology is appropriate for. And then now we're talking to the right people.
Is there a market out there that you're like, this has got to be one, they just got to figure out that we can do this? Like one where education is kind of that big factor that's missing?
I don't think so. I think what's happening is people are finding new solutions to problems that have existed for quite a while.
Right.
So now that we have a new method of making parts, it's appropriate to apply it to some things that have been confounding. So yeah, it's kind of a tricky question, but most of it is new applications, things that haven't been done before.
Right. Okay. We have a question from Bill Todd. Can you combine parts prior to sintering so they produce a single object?
Yes, they will weld.
How do you do that?
They need to have the same sintering temperature.
Like metals. I'm saying like two bronze parts can be sintered into one part.
How do you make sure that they actually get sintered together?
Proximity. It's got to be, as long as it's nice and tight, indirect contact, and a clean surface. Like a grain of sand in between there will wreck it. So you need perfection. But yeah, you can do it that way.
I mean, realistically,
can you also Brad, kind of use a 3D printing pen to draw a line of filament at the joint to help that as well?
Yep. Yeah. And you can weld it. And this is something we're encouraging more, is the 3D pen type stuff. Yeah. And a soldering iron. So you can post-process your part after it's been 3D printed and continue to manipulate it.
I guess that makes sense. That's how we do it in the non-metal laden FDM. In my head, I'm like, no, you don't want to use a 3D pen because it'll destroy it. And it probably will destroy it, but like they're totally $30.
Oh, the pen? No, the pens weren't. No. Destroy the part or destroy the pen?
The pen. It'll destroy the pen.
Nope. No, they work forever. Here's a part. Oh. I called this my freehand metal project. I don't know if you can see it.
Yeah.
So it's just ooze I ran out onto a piece of paper and then sintered. So we just used the $5 eBay 3D printing pens. And you can sort of use it like filler material when you're welding.
Yeah, it's a hand TIG welder basically.
Yeah.
Yeah. Okay. So does that welding process, does that affect the shrinkage rate? Because if you've got two walls that are touching, those walls are going to try to separate some, wouldn't they?
It can. This one of the things you have to watch for is delamination.
Right.
So when you're printing your part, this is part of designing for additive manufacturing. You want your infill to overlap the walls slightly, so everything is well attached. Otherwise, yes, you can have places that don't have enough metal will tend to delaminate.
Okay, interesting. This is so cool. can we talk a little bit about the DFAM process? Some things that people should be looking out for when they're looking to design for this, because I know, I don't know if Dom is still in here, Geek Toy Box. He seems to be very interested in this, and I think initially a lot of us might choose to use the printing service where we design the part, we send it to you, it gets printed, sintered, and then shipped back to us so that we can get a feel for it before we're ready to drop, you know, the kind of coin on getting some rolls ourselves. So what are some tips and tricks to more or less ensuring success when it comes to metal 3D printing?
Keep it simple. Large solid objects are more challenging than simple thin ones. And right, here's just where I was about to go. Generative design makes parts that are perfect for our process. And this is, and if you look at the way the parts are shaped, the organic nature of generative design,
right,
those work great.
It's hard to print that stuff, but yeah, it's pretty.
Well, you need a computer program to make it for you. You know, your slicer is going to apply supports where it needs to. But the cool thing about generative design, I get excited about this topic too. You know, it's only applying material where it needs to be. So in the picture on the right here, this larger picture with the 4 different parts,
Mm-hmm.
in the upper left one, you can see this part clearly was made for the manufacturing process of machining.
Right.
It started as a block, material was carved away. And then as we move to the right, this part in the lower right was made for the manufacturing process of 3D printing. So we're now, you wouldn't machine that part. It would absolutely not be practical. But with 3D printing, awesome. Your slicer is going to apply supports, and you can 3D print it in a cinch. So generative design allows for lightweighting everything. It allows for combining assemblies. And we're going to start seeing more things like this as we go into the future. So the objects around us are going to start looking different.
Yeah, it also lets you use higher performance materials where you wouldn't necessarily want to machine that from titanium. 3D printing it from titanium uses only a few grams of material, and you get a much more high performance part.
Right.
So the price point shifts when you go from subtractive to additive manufacturing. It's just a different game.
Definitely is. Yeah, I've wanted to play around with generative design, but boy, that's a different animal, to say the least.
Yes.
Different.
Now, Brad, could you you're not a regular person, you have incredible talents, but could a regular person go into their normal Autodesk program and generatively design something themselves, or does it take the computer to do it?
You basically, what you do, this is the Autodesk strategy. You go into Fusion 360 and you'll create a part. But what you do is you're giving it parameters. You're telling it it's going to have this amount of pressure in this direction on this area. So it's more of a data input task than it is an engineering task, which is the other part that's interesting about the whole concept, is the descaling of high-tech engineering. That's a whole different topic. But yeah, at that point in the Fusion 360 model, you hit go and it goes up into the cloud, and they iterate through hundreds of thousands of versions and then give one back to you that you might like. So no, you don't directly create a generatively designed part, but you can create things that look sort of like that. And if you use that as your model when you're designing parts, they print well and they sinter well. So it's not a bad strategy, and there's a term for it, and I meant to look it up before this and I forgot. But
you're fine. I don't know it either, so we're good. Maybe we'll get lucky and someone in the comments will know and be able to tell us.
Well, they use it for lightweighting, so you'll have what used to be a solid part, but instead it's made out of thin bars and such. But, oh well.
I'm drawing a blank too.
Yeah.
Is it topological optimization, which I also like to say because it took me a while to be able to say that.
Nope.
It's all good. I want to shift back to the business side of things, Tricia. What was it like, kind of going into a president role of the company and then watching it kind of mold itself, if you will, through this process over the past few years? What was it like for you?
It's been every day is very interesting. It's been incredibly challenging. I've definitely grown a significant amount through the process. Entrepreneurship itself is not for the faint of heart. And launching a new technology into a non-existent market is definitely requires some persistence and resilience. But it's incredibly rewarding. It's like watching a child grow up. And they gain skills and they learn how to navigate the world, and then they start doing it sort of independently. So it's kind of like that. And my job is to nurture it along and guide it on its path. It's very rewarding and it's exciting. I love working with people from all over the world. So just watching the whole thing emerge and create its own life is really incredible.
What were some unexpected challenges that you dealt with by being thrust into the into the public face of the company, basically?
Well, I did not expect some of the unfinished projects that I walked into in the very beginning, like the Kickstarter that Brad was talking about. And then also this trophy project that he had committed to. That was, Brad, what was it? The 3D Printing Industry Award?
Oh, hang on. I have an image here. I want to, this is its own story.
And Grant said he's having Michael Petch from 3DPI on his podcast in a few weeks.
Yep.
I asked him about it.
Brad had committed to making something like 27 of these things. They're absolutely beautiful, but you can see it's a really complicated shape.
Yeah. So, yeah.
Yes. So I think there was a contest and someone picked the shape. So, and the final product is a trophy that was sent out to all the winners. So these are all sintered too. They went through the printing, debinding, and sintering process in a brand new technology that had only existed for a couple of years and was still rough. In this very complicated shape. And when I first saw these things, I had no idea the complexity involved here. I just knew that these things needed to get made because the people were really asking for them and we were way overdue.
Right.
So shoring up some of those early projects, that was a little bit surprising. But I think also the people that I was going to get to talk to, and the people in the universities and the people in the military and the people, the super creative people who are working with 3D printing in general. I didn't really realize the hyper creativity of the industry that I was walking into.
Yeah.
And also the hyper creativity of just the Virtual Foundry itself and everything that Brad does and puts together. So that's been really cool.
Yeah, and it's all these people, and we most of the people that are users at home are, they work in high tech. So we kind of get to follow along and get involved in these situations where we're getting to know people that are working on just crazy projects that the world has gotten so much smaller since I started this company. I think that's one of my key observations.
Well, one thing that really surprised me and I loved was that there is a name for money in space, and it's called the I haven't looked it up. Hold on. Let me look it up before I say it again. But there's a whole name for the economy of money in space and money that can be made in space. Nope, I'm not gonna get it. I should have said it. But I got really excited about that. I never really cared that much about space from a scientific perspective. But when I learned about that business can be done there, that was very exciting to me. And we got this moon dust project, and that one's been going on for a while. That was another early project. And hearing that there are some products that are more economical to make in space, like you take the stuff up, put them together up there, and then bring them back down. What? That's crazy. So, learning about stuff like that and stuff that can happen in space and all of the new stuff that's possible because of 3D printing and additive manufacturing technology, that's really awesome.
Yeah.
It's dope, like the kids say.
Uh, yeah.
I want to take a moment and go back to the trophies. So
Yep.
this is one of a young entrepreneurial's naivety. I thought that I was going to make those and everybody was going to see them and fall in love, and it was sort of like a publicity stunt for me at the time.
Right.
And I committed to this just as we were moving out of the basement. So Tricia said it was technology that was 2 years old. It was more like 6 months old at that point. So I made the trophies, but I have pictures of sort of like the CEO of Stratus is holding one and people like that. So I was able to put parts into the hands of executives in the largest 3D companies in the world. It was a gimmick that really didn't pay off.
Some of these things, you know, I make these decisions. I made a lot of those decisions early on where it's like, probably shouldn't have done it like that, but you know, whatever, we did it, we're here. But it is, you kind of have to learn the hard way unless you have someone that's going to hold your hand and walk you through the valley of shadow and death that is running your own business as a creative. It is incredibly difficult to do that because historically speaking, no offense to creatives, we're not great business people. No offense to great business people, not always great creatives. And to find someone that has both of those skills is pretty amazing. And Tricia seems to be running a lot more of the business side while you get to do all the fun creative things. But it seems like there is a lot of crosstalk that occurs there, and that's nice, right? A lot of businesses will say, you just go do your job, leave me alone, let me do mine. Whereas this seems more like you guys are talking constantly. There is a working relationship that is good. And I like seeing that. It's not often that we get to interview more than one person from a company at a time. It's also not often that the two people that we get to interview are both incredibly intelligent in very specific fields, but have a lot of crosstalk back and forth. That to me is a lot of the value here. But from the small business aspect, doing those types of events, making the trophies, and you know, doing the greater good cause projects that you at least think are greater good in the beginning, they really do help add some of that mental stability that you need in the business from time to time. You know, the secret that is unfortunately not spoken enough is that building a business is incredibly taxing on not just your wallet, but on your mind. How do you relax and take a break away from the business? Because before we went live, Brad, you were telling me that you kind of more or less live at the shop at this point. You're always there making cool stuff. You being at the shop on a Saturday is not unreasonable, where Tricia was only a half mile away and wanted to do it from the shop because she's got the cooler background.
Right. So I have the luxury of the sort of my profession here blurs into my hobbies and my passions. So they're all kind of the same thing.
Like
so for getting away from it, I have a newborn granddaughter. So
congratulations.
Thank you. And this has actually had a pretty significant impact on how I deal with things at the shop. So it's been an interesting shift in perspective. I've lived in this shop 24/7, not literally, but worked that hard for the last 7 years. So it's time to change things up a little bit.
Have you made her any 3D printed metal toys yet?
No, not yet.
That's on the future plan though, right?
Yeah, she can have all she wants.
Spoiler rotten, right? The way you should. Well, this has been awesome. I want to thank both of you for coming out. Tricia, thank you so much for, one, agreeing to do this, two, setting it up, and convincing Brad that he should come on and hang out too. This has been amazing. And, we've talked previously with Sarah Gerke from Nexa 3D about how we need to be pushing a lot more of DEI in the industry and showing off the women powerhouses that run a lot of these companies. And Tricia, yeah, all boxes ticked right there, right? You are so great at this. It's like you were born to do this.
Yeah, there is no Virtual Foundry without Tricia.
There you go.
Thank you for saying that. I do feel as though I've found my home in entrepreneurship, and I am very thankful that I get to be a part of this project.
Yeah.
Yep.
Anything you guys wanna end with? Anything you want to tell people? Any shout outs you want to give?
Well, I would like to say something in defense of the creativity of business people, in that business is its own art. So business people are very creative in the art of business.
There's
true.
lots of problem solving to be done. That's for certain.
Yeah. Well, thank you both for coming out. I would love to do this again sometime in the future, like when you're releasing a new material, we can kind of show it off here live. I think that'd be a lot of fun. We'll definitely have to keep in touch, and I am going to be getting myself some material because I have a feeling we should be making a video or two about printing metal and what it takes to upgrade a standard Ender 3 to print metal filament. I think that would be a lot of fun. It might give me a good reason to buy a kiln. So
yeah.
And I'm sure the Better Three Quarters would hate to have a way for her to do more precious metal clay and other, creative projects. So I'm sure we can figure something out. But
nice.
Thank you both for coming out, guys. Go through the description. There's tons of extra information there. Links to the Virtual Foundry. Go take a look. Get some parts. Get some filament if you're feeling adventurous, and make awesome. That's what this podcast is called for a freaking reason. Everybody here makes awesome one way or another, and we are incredibly excited and privileged to have the Virtual Foundry here. But anyways, stay safe out there. Don't forget to call your loved ones, and as always, keep making awesome with awesome people like the Virtual Foundry. Season 2, episode 24. Leave a like on the video and subscribe, and the things I'm supposed to say as a YouTuber. Take care.